Mercury is the smallest and also it is the innermost planet in the solar system. Its landscape may look like being on the Moon. Since it is a rocky planet covered with craters, it has almost no atmosphere, and on the other hand, Mercury doesn't have any moons. A single year on Mercury lasts 88 Earth days, but due to its slow rotation on its axis, a day lasts twice as long. That means that if you could stand on the surface of Mercury, it could take a shocking 176 Earth days for the Sun to rise, set and rise again to the same place in the sky. The orbital eccentricity of the planet is the largest of all the planets in the solar system. When at perihelion, that is to say, the orbital point where a planet is closest to the Sun, Mercury is about 46 million kilometers from the Sun. And at aphelion, the orbital point farthest from the Sun, it is at a distance of almost 70 million kilometers. Because of this X-shaped orbit and of its sluggish rotation, from some parts of the planet's surface the morning sun appears to rise briefly, set, and rise again. Also, the same thing happens in reverse at sunset. As already mentioned, Mercury's surface appears heavily cratered and is similar in appearance to the surface of the Moon, although there also exist large areas nearly free of craters. As a comparison, 413 craters have been counted on Mercury, while on the Moon more than 1,600 craters exist. Volcanoes have not been identified on Mercury. However, the surface includes vent holes which appear to be the source of material thrown out by volcanic explosions. Mercury has a very tenuous and highly variable atmosphere, which, for this reason, it is sometimes called an exosphere, which is constantly pushed by the sunlight in the direction away from the Sun, creating a comet-like tail behind the planet. The main constituents of this exosphere are oxygen, sodium, and hydrogen, and in less proportion there are also helium, potassium, and a mixture of other gases mentioned currently as trace elements. Having almost no atmosphere to retain heat, Mercury has surface temperatures that vary diurnally more than any other planet in the solar system, ranging across the equatorial regions from minus 173 degrees Celsius at night to 427 degrees Celsius during the day. However, in the polar regions the temperature is always below minus 93 degrees Celsius. In comparison to other planets, Mercury is not easy to explore. For example, it is very difficult to put a satellite into orbit around the planet. The planet speeds very fast, so the velocity required to reach it is relatively high, and Mercury's close proximity to the Sun means that the spacecraft will be accelerated even farther by the Sun's gravitational pull, requiring significant fuel consumption in order to accelerate it for orbital insertion. A landing mission would have even more demanding fuel requirements, because Mercury's very tenuous atmosphere hinders the acceleration without substantial fuel consumption. Despite these difficulties to reach the planet, two spacecraft from NASA have visited Mercury. The first one was Mariner 10, which flew by Mercury 3 times in 1974 and 1975. The third flyby was the closest encounter with the planet, passing at 327 kilometers over the North Pole. Virtually all that was observed with Mariner 10 was new data, since it is very difficult to study the planet from the Earth using telescopes. The proof detected Mercury's magnetic field, which is global and stable, and its strength is 100 times less than the Earth's magnetic field. On the other hand, Mariner 10 took visual data of 45% of the surface, which allows scientists to speculate about the composition and age of the planet. The second spacecraft to visit the planet was Messenger, which was launched in 2004, and it entered orbit around the planet in 2011. It achieved 100% mapping of Mercury in 2013 and continued collecting scientific data until April of 2015, when the probe exhausted its fuel and was allowed to crash onto the surface of Mercury. Data collected by Messenger showed the existence of large amounts of water present in Mercury's exosphere, which was an unexpected finding. Messenger also provided visual evidence of past volcanic activity on the surface of Mercury, as well as evidence for a liquid iron planetary core. The probe also constructed the most detailed and accurate maps of Mercury to date, and furthermore, it discovered water ice as well as organic material in permanently shadowed craters in the North Pole of the planet. Messenger provided a great amount of data, some of which needs still to be processed. However, a new mission called Bepi Colombo is now going to continue and enhance the work started by Messenger. Bepi Colombo is a joint mission between the European Space Agency and the Japan Aerospace Exploration Agency. The mission involves 3 components, 2 of them built by ESA and 1 built by Japan. During the launch and cruise phases, the 3 components are joined together. But on arrival at Mercury, they will separate. One component is the Mercury Transfer Module. Its role is to carry 2 science orbiters to Mercury and to support them during the cruise. The science orbiters of Bepi Colombo are the Mercury Planetary Orbiter built by ESA and the Mercury Magnetospheric Orbiter built by Japan. The Bepi Colombo system, including its fuel, comprises a stunning 4,000 kilograms of mass, and it was launched in 2018 from the French Guiana. In October of 2020, it made a Venus flyby, and it is expected to be inserted into the orbit of Mercury in 2025.